Hello, this is Miss Bryant, and this is the midterm review continued on to Unit 4. Thought maybe I could fit 3 and 4 in the same video, but it looks like we're going to need one more for Unit 4, so here we go. At the top of the last page of your review, you have a matching section that is going to go over the transformations of the parent quadratic function, how they would shift or reflect. And so I wanted to help you match a couple of these on this slide. Here's some basic reminders here. This is our vertex form, y equals a, parentheses, x minus h squared plus k. The red a value on this matching section is going to be 1 the entire time. But if we did have an a value that was a 2 or a 3 or a whole number that's greater than 1, we would have a vertical stretch. If we had an a value that was between 0 and 1, we would have a vertical compression. And then if a ended up being a negative number, or if there was a negative sign in front of the parentheses, that would be a -1 a value. Anything negative is going to reflect over the x-axis. Inside of the parentheses is the value of h here, and that is going to shift our parabola left or right, and those signs are going to feel the opposite. And then the k value on the outside of the parentheses added after x has been squared is going to shift the graph up or down. So I'm going to go ahead and delete that so that we can see all the matching options. And we're going to talk through just a couple of these. Let's start with number 41 is your parent graph. So let's at least make sure we can identify what that parent function looks like, the parabola that has not been changed at all. It's going to have a vertex at 0, 0, key points that go over 1, up 1 on each side, and over 2, up 4 on each side, and over 3, up 9 on each side. So think about 1 squared is 1, 2 squared is 4, and 3 squared is 9. So it looks again like none of these parabolas have been stretched or compressed from those key points. They're appearing on all of our parabolas. So that would be the correct answer to match for y equals x squared. Now we did say that that plus k value at the very end, like in number 39, there's a plus 2, is going to be a shift up or down. Since the 2 is positive, I'm looking for a parabola that has shifted up. Couple of them that I see shifted up. This one's up, this one is up. This one is up higher than the 0, 0 vertex. And so the other thing that I'm looking for is that value of h, which is inside the parentheses, and that is going to shift the opposite from what we would kind of expect with the sign. So since it's a -1, we would be shifting to the right. And so the vertex that has shifted to the right 1 and up 2 is a4. All right, let's check out another one. Number 42 has both of those kinds of shifts as well with a -4. So I would be looking for a graph that has moved down 4, which is pretty far down from that 0, 0 vertex. I actually only see one graph down here that has moved down to the -4. And also I would be looking for a shift that is to the left 3 because that is a +3. And so it has also shifted to the left 3. So A7 is the correct answer for 42. Now if it only has one or the other, for example, one more, number 46 doesn't even have parentheses at all, which means that there can't be a shift left or right because the h value would have been 0 inside of the parentheses. And then the +3 on the outside edge does mean that we've only shifted up 3. And so this parabola right here has shifted up 3 from the 0, 0 vertex, but has not shifted left or right. Now I would like to point out that's a typo. That should definitely say x squared plus 3. So I think you guys are good to match the rest of those on your own. We're going to actually look at the last graphing example first because the function is already in vertex form. So question 49, how can we graph this? Let's think about first what we were just talking about and how it shifts. And so this parabola from the parent function will move to the right 3 because of the minus 3 and up 5. Also, this one does have a negative 1a value in front of the parentheses, so it is reflected over the x-axis. All right, now let's grab those key points we were just talking about. So the parent function has 0, 0 as the vertex, and then like we saw, 1, 1, 2, 4, 3, 9. We're going to use those same points. We just have to make sure that we start from our new vertex. So what is the vertex? Well, if it has shifted to the right 3 and up 5, then my new vertex should be 3, 5. So I'll go to my graph and plot 3, 5. And from that dot, I'm going to be graphing where this function goes. And so I know that the key points are not going to be stretched. They're going to stay the same or compressed, but they are going to go down because we have reflected over the x-axis. So I'm expecting this to be a frowny face because of that negative sign right there. So then if I travel from my new vertex over 1, down 1 on each side, those are going to be the first key points on the parabola, and then over 2, down 4. So those will be the next key points on this parabola. And then we can connect those. That was pretty good. And make that shape of the parabola. Now this one does ask me to find the y-intercept as well. We did already talk about the vertex. I'll point out it is a maximum now since it is the highest possible point on our graph. But to get to that y-intercept exactly, we're going to need one more key point. So if we use this 3, 9, again traveling over 1, 2, 3 from the vertex, but then traveling down 9, we should hit the y-intercept exactly. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And so at the negative 4, and of course there would be a dot over here on the other side that is symmetric, so I could just keep on continuing that parabola shape down until it crosses the y-axis, and the y-intercept is 0, negative 4. So that's a quick review of graphing. The midterm's not going to ask you to graph anything by hand, but you will need to recognize what the graph looks like when you are given the graph or the equation. So what if we're given something that's not already in vertex form? Well, question 47 starts in standard form, which is 2x squared minus 8x plus 11, a trinomial. I can see that it still has an a value of 2, and so actually in this case, the graph is going to be stretched a little bit. The first thing we need to do in order to be able to graph this, though, is put it in vertex form, because other than the a value, I cannot tell whether this has shifted to the right or left or up or down. So we need to complete the square in order to put it in vertex form. So completing the square is the process where we will draw perfect squares with the information from the trinomial that we are given. This one starts with 2x squared, which is going to be drawn with our two big x by x squared blocks. From there, we have diminished the sides or decreased the sides by a few inches, and we need to go figure out exactly how to divide that up. But we have negative 8 of the x's, or negative 8 rectangular pieces to put onto these diagrams. Well, the first thing I need to do is make sure I evenly divide those 8 rectangles onto each picture, which means each picture should have 4. I don't want to put all 4 on the same side. I want to evenly divide the 4 rectangles, 2 on one side, 2 on the other, creating perfect squares. So now that I've distributed out all of the rectangular minus 8 pieces, I can focus on the plus 11, which is those small squares that I typically just draw as dots in the corner. But remember, we have to draw whatever we're given, so I'll go ahead and draw 11. So I've got 1, 2, 3, 4 in that diagram. 5, 6, 7, 8, and they're full, but I still have 9, 10, 11 to make sure that I draw all of the small squares that I'm given, which must mean that I have some extras right there. So how do we write the other area expression for this diagram, which is the same thing as our vertex form? Okay, so focus on one of your diagrams and tell me the length across the top of that diagram. The length across the top of this diagram would be x minus 2. Don't forget that those were negative rectangles, okay? So the area of one of the diagrams is x minus 2 squared, okay? Now, consider the fact that you actually had two completely separate diagrams, and so the 2 in front of the parentheses will indicate that you have two of the same diagram. And finally, don't forget your 3 extra small squares. Now this is what the graph looks like. I need to go ahead and add my extra plus 3. Okay, perfect. And so that is now vertex form. So I can take the 2 and think about that as my vertical stretch, but I would actually want to use the h and the k value first to go plot my new vertex, which would be over 2 up 3. And so this new vertex right here, over 2 up 3, is from the to the right 2 and up 3 shifting that is noted in my vertex form. It is a minimum this time. And then the only other thing key feature-wise that it's asking me for is the axis of symmetry. So I'll just point out that this 2, because I know we haven't graphed a ton of these, is a vertical stretch of 2 right here, because this parabola is twice as tall as what we would expect from the parent graph. Every other graph that we have graphed, when you go over 1, you would only go up 1 square. These are going over 1 on each side and then up 2 blocks. So any of the key points that we would be using are going to be multiplied by 2. The y values are multiplied by 2 because they're twice as tall. The axis of symmetry, you guys know, divides that parabola right down the middle into symmetric halves, and so it is at x equals 2. Okay, one more. So the last graphing problem is a little bit easier to complete the square, except for the minus 3 at the end. And so again, I can't really tell much about the function if it's in standard form, but I need to complete the square first and then graph it. So if I start with one big square for this one, which is my 1x squared this time, and then I only have been given 2 rectangles, so that's pretty simple here. We'll just put 1 on each side. So that comes from that minus 2x. And then it says that I am, this is weird, already missing 3 of those small squares. So I can't actually draw any of them because I'm already missing them. And I'm missing the one that I need for my diagram as well. So I'm going to go ahead and count that as I'm missing the one that I need to complete my picture, and I was already missing 3 before I even started. And so across the top, I'm going to find that the length of the side of my diagram is x minus 1. Again, don't forget, if this is a negative value, I'm actually decreasing each side. And so the area, if I wanted to rewrite it, would be x minus 1 squared. And I was missing 3 and missing the 1 square that it took to make my diagram. So I'm actually missing 4 altogether. Okay, so this will shift to the right 1. Signs are opposite inside the parentheses, and down 4. Let's see what the picture of the graph looks like. To the right 1, down 4, there's the new vertex. And on this one, it has not been stretched or reflected or compressed because the a value was just a 1 in my standard form and in my vertex form, so the key points are normal. You can see if you follow those key points over 2 and up 4 that you have nice neat x-intercepts on this one, which are at -1, 0, and 3, 0, and then that axis of symmetry again cuts it into 2 equal symmetric parts, so x equals 1 is the axis of symmetry.